Here are the steps to writing an ionic compound. It's called the S.O.X.S method. First, you write the symbol for each element or compound. Then you write the oxidation number of that element or compound. Then you crisscross and just bring the number down without the sign, plus or minus, and then you simplify your new subscripts. This will all make sense in a second. But to help you remember it, it's S.O.X.S, symbol, oxidation number, crisscross, simplify. All right, now let's see how to use the S.O.X.S method. Our first example is sodium chloride, and with our first step is to write the symbols. So sodium symbol is Na, chlorine symbol is Cl, and then if you look on the periodic table and if you remember what we've talked about in our last unit, sodium has an oxidation number or a charge of +1, and chlorine has an oxidation number or charge of -1. So then, once we have our oxidation numbers, sodium with +1, chlorine at -1, we crisscross those numbers down. So sodium's number goes down here and chlorine's number goes over there. So then sodium now has a 1 and chlorine now has a 1. Remember, we remove the signs, the plus or the minus, when we crisscross. Then our last step is to simplify it. Now, since sodium and chlorine both have a new subscript of 1, we can just write NaCl. And we're done. Now let's try an example with a transition metal in it. This compound, iron 2 oxide, has a transition metal of iron and a main group element of oxygen. Remember that IDE is just an ionic form of that element. So for this one, we're going to write our symbols. Iron is Fe and oxide is O. Then you might be asking, well, you didn't tell me how to do the transition metals. Well, in this one, transition metals, when you get the name, is actually easy. So you look at the Roman numeral beside or right after the transition metal. So for example, this one, iron, is +2, and oxygen we know is a -2. So then just like we did before with the sodium chloride, we crisscross our new numbers, and so Fe2 and then iron or oxygen 2. And then our last step, just like before, is to simplify. So in this case, iron has 2, oxygen has 2, so your new final compound would just be FeO. For our next example, let's look at something that has a polyatomic ion in it. All a polyatomic ion is an ion that has multiple atoms. For example, this one, copper 2 nitrate, the nitrate is our polyatomic ion. So when we go through these steps and we write our symbols, we need to make sure we're writing the right one. So for polyatomic ions, what I would recommend that you do is go and look on your news you can use, which if you see this big chunk right here, this is all of the polyatomic ions that you need to know. So in this case, nitrate is NO3 1-. So when we write our symbols, copper we know is Cu, and then nitrate is NO3. Then we write our oxidation number. So again, for copper, you're going to look at this Roman numeral. So this will be copper +2. And then nitrate, remember from our news you can use, has a -1 charge. So then we continue it just like normal. We've got our symbols written, we've got our oxidation numbers written, and now we crisscross. And so now the only thing that's different when you write the formula for a compound with a polyatomic ion in it is that if your polyatomic ion has a new subscript, you have to put the polyatomic ion in parentheses. So for example, this formula, copper 2 nitrate, is CO parentheses NO3 parentheses 2, because this says this subscript has 2 nitrates, so 2 NO3s, not 32 oxygen atoms. For our last example, let's look at something that we have to simplify. So for this example, we have a transition metal, titanium, and a polyatomic ion, sulfate. So for titanium, we know what the symbol is. It's Ti. And then for sulfate, we'll look through our news you can use and see that sulfate is SO4 and it has a -2 charge. So then we write our symbol, SO4, and then our next step is to write our oxidation numbers. All right, for titanium would have an oxidation number of +4, and for sulfate, you look on your news you can use and see that sulfate has a charge of -2. So we've got a +4 titanium and a -2 sulfate. So then we crisscross. We have a 2 over here and a 4 over there. And so now what I'm going to do is write Ti2 parentheses SO4 4, because now you can see that we have a 2 and a 4, which we can simplify by dividing by 2, which means our new compound is Ti parentheses SO4 parentheses 2.